So this is what's actually happening, in a diagram. Which one of these diagrams show case one where things are visible? Well, of course it's the upper one, because light, this red arrow, is reflecting of this border of objects into his eyes so he can see it. Now in this diagram, what we call case 2 is happening, the invisible case. So as you can see over here, the red arrow, the light, is just passing through these two objects, which in this case are vegetable oil and Pyrex test tubes. But why is light passing through? Again, you may pause the video to think about it. Well, you see, objects have a magical number. Yeah. My point is, any object has a magical number, and that magical number is called refractive index. Another key term over here, and this refractive index can calculate what is called reflectivity, which is briefly the chance of light reflecting. Anyway, reflectivity is the chance of light reflecting. So basically, one ray of light comes, and then if that light reflects or not, if it just passes through. That's what reflectivity is, and it can be calculated by that magical number called refractive index, as I told you. And just a key thing over here, when two objects' refractive index is the same, like this vegetable oil and Pyrex test tube case, which has refractive index of 1.474, things become invisible. That means the reflectivity, how much light reflects, is 0. Well, let's see how to calculate over here in this equation. There's a way to calculate. This is a kind of equation found by a physicist called Fresnel. He's a French physicist, by the way. So this is an equation he found, he discovered, which is simplified. Okay. So this equation right over here, all equal and all that. So the important thing is this R is the reflectivity, and this N is the refractive index. So let's look at some examples of the Fresnel equations. As you can see over here, we have Pyrex test tube, which has refractive index of 1.474, which is N1. While that we have water, which has refractive index of 1.333. So when we do all the calculation of subtracting and adding only, we get this kind of fraction, and then we only have to divide this, which approximately equals 0.05. That means that R, or the reflectivity, equals 0.05. Now let's take a look at case 2, where this Pyrex test tube also has refractive index of 1.474, and the vegetable oil has the same 1.474. And when you do all the calculation, we get divide this, and it equals 0. So the reflectivity equals 0. What does that mean? Well, reflectivity equals 0. That means the Pyrex test tube is invisible. And over here, the reflectivity is not 0. That means the Pyrex test tube is visible. So here's a table of different refractive index. The materials, and have refractive index. Okay, so a pair of some materials over here with the same refractive index. Can you? Let's see. Well, water at 20 degrees Celsius and super absorbent polymer balls have the same refractive index. What's the refractive index? It's 1.333. It's the same refractive index. That means that maybe the reflectivity might be 0. So chances are, when we put super absorbent polymer balls in some water, it might become invisible. But let's see about that over here. Whoosh! I got some super absorbent polymer balls. See? And when they go into water, surprise! So there you go. The super absorbent polymer balls. Even if it is on his hand, it became invisible. Yes. Alright. This is a graph version of some different materials and the refractive index. As you can see over here, the green and the yellow have the same refractive index. I mean the green and yellow are series with same refractive index. Two pairs, right? Super absorbent polymer balls and water, parasexual and vegetable oil. So here in this blue column, there are many different materials, and let's see if you can find two liquids that has a really similar refractive index to this parasexual and vegetable oil. Which one is it? Well, I think that this one. Virgin olive oil and sesame oil. And as a matter of fact, they have a really similar refractive index, which you can view on the chart over here. Alright, see? Sesame oil has refractive index of 1.4645 to 1.4665, while virgin olive oil has refractive index of 1.4677 to 1.4665. So they're fairly close to 1.474, which is the refractive index for parasexual and vegetable oil. Okay, so when we put this parasexual and vegetable oil inside this magically appeared mixture of sesame oil, virgin olive oil, and vegetable oil, what do you think will happen? Let's make a hypothesis. Alright. I guess so. Think about your hypothesis, because I'll start the experiment right now. Let's see what happens. Alright, there we go. You can see, you cannot see the parasexual almost, but you can only kind of feel the silhouette of the parasexual. Just kind of feel. Yes, it's fairly close to invisible though. So now you have kind of a gradation. So over here with water, it's perfectly visible. Here, it's barely see it. Almost invisible, but not perfectly invisible. And this one, perfectly invisible. So, yeah. And the interesting thing is, when you think about the water, only has refractive index difference about 0.1 when you erase the 3 and the 7 4. But only 0.1, it can make a huge difference like this. So refractive index, small changes, huge difference. It has to be the same number to become perfectly invisible, but very similar number, like this. Okay, so let's get on to the conclusion. So a conclusion is just kind of a review for my presentation, for my case. Anyway, so how can we see objects? Well, we can see objects because light reflects off of any object really. How can we control light how can we control light with reflection so that we can make something invisible? Well, we can use a magical number called refractive index, and when two object refractive index are the same, the reflectivity becomes 0, so we cannot see that objects. Yeah, that's two main points of this presentation, or however you would like to call it. And these are my references. Thank you to the head squeeze and all that stuff. Thank you very much for your attention. For your attention, but wait a minute. Before you close this video and all that, I got one more surprise for you. Maybe one more thing to say. Okay. Let's see if I can find something here. Do you think I'll find something? Let's see. Oh, did you hear that? Yeah, there you go. So, oh, there we go. I caught it. See, this speaker is very good at hide and seeking because it maybe not seeking but hiding because it is clever in science. I mean, yes, it knows about refractive index. Oops. Yeah, and now you know about refractive index, so maybe next time you do hide and seek. I don't know if you can make it simple because there's no such materials that has the same refractive index as you do. Probably. Probably. As long as I search on the internet, there's no such liquids or materials like that. Anyway, so thanks for watching, and please check out our YouTube account down up there or down there or anywhere around over here. Probably it always changes, you know. So yeah, please check out YouTube account. And when you check my YouTube account, you might be astonished because I uploaded many music videos. So hope you like that. Maybe if you can, I'll be glad if you subscribe my YouTube channel and all that. I don't know, like my YouTube channel. Not like my YouTube channel, like my videos. Yeah, stuff like that. Comment and all that stuff. Yeah, so thank you very much, and that's pretty much the end of this video. Okay, thank you. Bye. Whew.